Hello everyone, my name is Guillaume Cardoen. I am a PhD student in the Software Engineering Lab of the University of Mons under the supervision of Tom Mens and Alexandre Descamps. And today I will talk about a large-scale empirical analysis that we have conducted on the presence and location of code clones in GitHub Action workflows. We all know GitHub is one of the most popular social coding platforms as of today. It features many useful tools such as Issue Manager, Pull Request Manager, Security Advisor, Wiki, and many others. But in particular, it features GitHub Action, which is GitHub's own CI/CD that we introduced in September 2019. As shown by our lab in SANER 2022, it became the most popular CI/CD used in GitHub projects only 18 months after its introduction. In line with the principle of configuration as code and similarly to other CI/CD tools, GitHub Action uses a YAML file called workflows in order to specify its automation configuration. A workflow has two main parts. The first part, the on key, specifies when the workflow should run. In our example, the on key specifies that the workflow should run each time commits are pushed to the platform or when a pull request is touched. The second part, the jobs key, specifying the different jobs that the workflow should execute, where a job is a sequence of steps, and a step is either a shell command that we will execute or a call to a reusable component called action. In our case, we declare a single job called lint. It runs on the latest version of Ubuntu, and as a first step, we use the uses key in order to call a reusable component called action checkout, which will put the repository inside our local environment. As a second step, we once again use the uses key with the reusable component action setup Python, which will install Python in our local environment. As a first step, we use the run key that executes a shell command. In our case, we install Python package manager PyP as well as a few requirements. And as a last step, we once again use the run key in order to run a shell command which will run rough our Python linter and output results in a format that GitHub understands. Now, other workflows, such as the one shown on the right hand side of the slide, might have some commonalities with the first one. As an example, it might also install Python, check out the repository, maybe install some dependency. And to avoid having common parts in the YAML file, GitHub introduced a few reuse mechanisms, such as GitHub Action Composite Actions, which allows you to copy-paste the step using a very similar syntax to the one of the workflows, add some metadata, and then if you want to reuse this step, you can just call the new composite action that you just created. As an alternative, you can also use reusable workflows, which uses the same syntax as the workflow we have shown previously. And when you want to reuse a complete job or a complete workflow, reusable workflows will allow you to do that simply by linking to the YAML file where the reusable workflow is. One could also decide to keep the common parts in the YAML, leading to some duplication. This duplication is often referred to as code clones. While there is no exact definition of what a code clone is, a widely accepted definition is that code clones are segments of code that are similar according to some definition of similarity. The definition is a bit vague, but it shows that what a code clone is really depends on what you want to study in your environment. In our case, GitHub Action workflow files. Clones are known to have some positive effects, such as an easier understanding of the code, it increases development space, and it might overcome some language limitation if the language is not expressive enough. However, it is also known to have some negative effects, such as reducing evolvability, it propagates bugs, and it leads to a higher maintenance cost. In a recent qualitative survey we have conducted with 419 GitHub Action practitioners, we found that most of them prefer to copy-paste rather than using the built-in reuse mechanism of GitHub. They feel that copy-pasting is more convenient and also more control and flexibility, while using the reuse mechanism adds unnecessary complexity to the project. Seeing that most respondents prefer to copy-paste, we expect to find a lot of clones in workflows. This led us to ask 4 research questions. The first one is, how prevalent are clones in workflows? The second one, which part of workflows are the most subject to clones? For example, do we find more clones in the event triggers? Or maybe we find more clones in the sequence of steps of some jobs? Are our clones distributed across different scopes? For example, do we find more clones within the same workflow file, or do we find more clones within workflow files of the same repository? And finally, to which extent could this clone be reduced by using composite action or reusable workflow which are built into GitHub Actions? To answer this research question, we started with an existing dataset by our lab of GitHub Action workflows that we published in MSR 2024. We took an updated version containing a bit more than 180,000 workflows coming from a bit more than 34,000 repositories, and all workflows were created or at least modified once from January 1st to August 25th in 2025. Given the time restriction of presentation, I don't have time to talk about each step, especially the points C and D in the figure, which are non-trivial. I invite the interested listener to check the paper for more details and contact me directly in case any questions should arise. In these 118,000 workflows that we analyzed, we found more than 364,000 clones representing more than 81,000 unique code fragments. In all the workflows we analyzed, a bit more than 2/3 at least one clone, and usually the clone size was between 5 to 9 key value pairs in YAML. We then set out to understand which part of the workflow are the most subject to clone. We found that a big majority, 81%, represented a sequence in the steps of jobs, and the second most common clone was the entire workflow, which represented only 4% of clones. Other clones represented all steps in a given job, some job in a workflow, or the workflow triggers, but to a lesser extent. Next, we set out to understand how our clones distributed across different scope. What we mean by scope is whether clones are within the same workflow, within different workflows of the same repository, or within different workflows of different repositories, all from the same owner. To do this, we computed three characteristics: the number of candidate workflow, which is the number of workflows that could have at least one clone in the given scope, the clone occurrence rate, which is the proportion of workflow with at least one clone with respect to the number of candidate workflows, and the median clone coverage, which is inspired by the test coverage, which represents the proportion of the workflow that is cloned. We found that clones are especially present in different workflows from the same repository, with 31% of workflows having at least one clone with another workflow from the same repository. And for the clone coverage, we found that it's especially high in workflow from different repositories from the same owner, with in median 55% of the workflow that is cloned with another workflow from another repository of the same owner. Finally, as the last research question, we want to understand to which extent could GitHub Action maintainers reduce the number of clones in their workflow files by using reusable workflows and composite actions. We focused on clones that were within the same file or within the same repository, as these are the scope that correspond to refactoring equivalent to extract method refactoring that we can find in general purpose code. We found that composite action could remove a big majority of clones in the same file, in the same workflows. To be precise, 83% of clones could be removed by using composite actions, whereas reusable workflow could remove around 2% of clones that were within the same file. We found similar conclusion for clones within the same repository. 75% of clones could be removed using composite action, and around 2% of clones could be removed using reusable workflows. Please note that this number are an optimistic estimation. It's not because we can remove a clone that we should remove a clone. Sometimes clones are more beneficial being there than being replaced by a reuse mechanism. To conclude, clones remain omnipresent in GitHub Action workflow, and they mostly occur within workflow steps, despite the built-in reuse mechanism that could be used to avoid them. They are more common between workflows of the same repository, and the built-in reuse mechanism of composite action could remove many of the clones from the same file or the same repository. That said, we don't know yet if we should use composite action to remove these clones, and we leave that question for future work, as well as further studies on the genealogy of the workflow clones, their evolution, their reuse practices, and maybe a better tool support for refactoring. Thank you very much for your attention, and I'll be happy to answer any question you may have.